Okay, good afternoon, everyone. Please have your camera on so we get started. Now, I didn't grade your quiz yet. Your quiz will be graded this weekend, and you guys will have a feedback. So each one of you, you go over your quiz. Once I grade it, you will have a feedback, and you will read, what mistake you did. And I will have this, I think I already have it, and I have the solution there. So over the weekend, I grade your quiz. Once I grade it, I want you to read the feedback, read the solution, and see what you did wrong. And if you don't understand your mistake, you have to let me know. Okay, so that's how it's gonna work for the quiz. All right, now practice problems. Which problems you guys had difficulties with? Because, okay, very good. So we're gonna start with the questions that you guys asked. So we're gonna start section 1.6. And okay, that's I did not understand PP2D. Leia, I didn't get what you mean here.
Practice problem 2D.
Yeah. Okay. Yeah. Okay, I should have understood. I didn't. Sorry. All right. So we're gonna start with 1.6. And 1.61, 1.62 are exactly the same type of problem. So I will pick one of them and you do it.
Okay, so I'm so sorry. I meant to say the worksheet 3D or 2D, and then the practice problem 1E. I'm just like having issues with the like figuring out what to do with it being a variable as a fraction on the bottom.
Okay, so I'm gonna start 1 now. Okay, and then we're gonna do 3. Okay, are you with me? Okay, let's start. Okay. So 1.6, we have the following function. And I'm doing 1.6 number 1. F of x is x squared plus 5x plus 6. Oh, sorry. Okay, it means f is a function. It's a rule. And the input here are all possible real numbers. This is what the input. So my domain here, all the possible real numbers. And my rule does the following. You give it an input, whatever you give it, it acts on it. So it does something to it, and it spits out whatever you give it, squared plus 5x plus 6. So that's really what my function does. So these are the input values, are every possible number. So we have a lot of inputs here. To each one is going to assign that. So we start answering the questions. I know that you guys ask for E and F, but I will work a lot on this problem. So first, part A is f of 4. So f of 4, it means my input is 4. What does f do to 4? That's what it does. It takes it, square the 4, then it does 5 times 4 plus 6. So it means it's 16 plus 20 plus 6. And if we add those, I get a 2 and I get a 4. This gives me a 44. Okay, so this is the basic questions that I'm sure all of you can do it. Now, I will do C. F of 1/2. Okay, so this has a fraction. And here what I want the answer to be 1 fraction. It means I don't want you to use decimal in this problem. And the reason is I would like you first to practice how you work with fraction, and that's crucial. So if I ask you to give the answer as a fraction, it means I don't want you to use decimal, and I don't want to use mixed numbers. Mixed numbers are good when you start learning fraction, but at this stage, mixed numbers are confusing more than anything else. So at this stage, we don't use mixed numbers anymore. Mixed fraction, I meant. I don't want you to use mixed fractions. I really want you to use just regular fraction. Okay, so what's f of 1/2? Okay, I will do that and then slowly. Okay. What does f do? Takes what you give it, whatever you give it. It takes it and square it. Plus 5 times, so that's multiplication, whatever you give it, plus 6. Okay, I will do that myself, is equal to. Now, what is 1/2 square? We've talked about that. 1/2 square, it's 1/2 times a half. How you multiply fraction? You multiply the numerators, you multiply the denominators. This is 1/4. Plus 5 times a half, it means a half plus a half plus a half plus a half 5 times. It means 5/2 plus 6. Now we're going to do common denominator. So common denominator here means I'm looking for a number that's a multiple of 4 and a multiple of 2 at the same time. So the common denominator is 4. So let's do that. So it's going to give me equal to. Okay, 1/4, 1/4. Plus, the common denominator is 4. I have a 2. I have to multiply this by 2 to get a 4. So I have to multiply the numerator by 2. Plus 6. Again, I want a 4. So I have to multiply 1 by 4. So I have to multiply the numerator by 4. So now, the minute I create this common denominator, the rest is easy. Now I can combine my numerator and I will get 1, because it's the same one. The same denominator, I can combine numerator, plus 24. And the rest is give me 34. 10 plus 24, 34 plus 1, 35/4. Okay. Now I want to start doing D. Okay. D. So they want me to find an expression for f of t plus 2. Okay. Now, in this case, what the goal of this problem when they put t and stuff is to start really helping us work with function in a symbolic way. It means t, I cannot substitute by a number. T has to stay a t in this problem. So we're learning how to work with functions symbolically because we have to. We cannot always make the input always in numbers. Sometimes we have to think at a little bit more symbolic level. So what's the f of t plus 2? So I'm going to, here, I will always write the function because it's not always in front of me. So that's the rule. It's x squared plus 5x plus 6. I keep it here so I can always go back. So what's the f of t plus 2? All right. That's equal to. Okay. What's t plus 2? So what does f do? Whatever you give it, it's squared. So if you give it the t plus 2, that's your input here. So this is going to give me whatever I'm going to give it, but it's going to square it. Plus, then what it does, it takes 5 times whatever you give it, whatever it is, t plus 2. And finally, it adds 6 to that. Okay, so that's the setup. Now, we need to simplify. And here, you don't have to write. I'm going to ask you a questions because since I've taught this class before, I know where some problems are here. So to simplify, I need to evaluate each expression. So before I do the good work, I'm going to ask you a question. Is this equal? That's a question. t squared plus 2 squared? What do you think? Yes or no? Absolutely not. Fairly common mistake, crucial. A fairly common mistake that students do is that whenever they see square, they square the first plus square the second. Absolutely false, because I can give you numbers. So for example, watch, if I take 3 plus 2 squared, that should be 5 squared, that should be 25. However, if I take 3 squared plus 2 squared, that's 9 plus 4, which is 13. So definitely I cannot distribute. Is that clear? Write it clearly for yourself, because I'm expecting a lot of students doing this as a mistake. So what is t plus 2 squared? Okay, there is no, it's not hard. It's t plus 2 multiplied by t plus 2, pure and simple. You write it and then you expand it. Are you with me? So now I'm going to do the correct stuff. What's this? It's t plus 2 times t plus 2 plus 5 multiplied by this. I need to distribute, which is going to give me 5t plus 5 times 2, it's a 10, plus 6. This is not simplified yet because I have this product, so I have to take care of it. Now I'm going to distribute this one. T times t squared plus 2t. So, and then plus 2t plus 4. So as you realize, t plus 2 squared is not t squared plus 4. It's t squared plus 2t plus 2t plus 4. Okay, it's simple, but the tendency to do a mistake is actually quite a bit. Now finally, I collect terms that look alike. T squared, I have 2t, 2t, and 5t. That's going to give me the 7t. And finally, I have 4 and 10, 14. 14 plus 6 equal to 20. All right? For those who got it correct, you're fine. For those who did not, okay, that's fine. Now, E, and then I do F. E, again, we're doing function symbolically. That's really the goal of those problems, how to work with it.
Professor, I'm sorry. Wouldn't it be 90?
Am I being very sloppy?
Because
Yes.
4t.
Yeah. Thank you very much. I should give +1 for those who correct my mistakes. All right. F of 2 over y now, right? Yeah, 2 over y. Okay. I'm going to give you a little bit of time for you to figure it out. So I want you to find it and express it as one fraction. And then I'm going to get back to you. Okay, I'll give you, I think, a minute for that, and then I'll get back to you and see how did you get it. Please do it very, very slowly. That's the function, that's the rule, and that's my input. Okay, do it, and then I'll pick one of you. Do it very slowly, take your time, kind of. Please, those who don't have their camera on, please put them on. Okay, who's ready? Cindy, are you ready?
Yes.
Okay, go for it. Guide me word by word. I'll write whatever you say.
Well, first you're gonna put it into the equation.
Yes.
So 2y, well, 2 over y squared plus 5 times 2y.
You mean 2 over y.
Yeah. Plus 6.
Good. Now, you want to simplify. What did you do?
You're gonna put 2 over y times 2 over y.
Yeah.
And that's gonna give you 4 over y squared.
Let's give me 4 over y squared. Here.
And then for the 5 times 2 over y, I got 10 over y.
Absolutely correct. Because it's 2 over y plus 2 over y plus 2 over y plus 2 over y. 5 of them means 10 over y. Or you can say it's 5 times 2 over 1 times y, whichever you want. So far, so good. Keep going.
And now you have to find the common denominator.
Okay,
So
common
in this
denominator.
case,
What's the common denominator?
y squared.
Absolutely. Y squared is the common denominator. So now keep guiding me. You're doing great. So keep going.
For 10 over y, you're gonna multiply that by y over y.
Yeah, because what is y squared? Is y times y, correct?
Mm-hmm.
So if I want y squared here, means this has to be multiplied by a y. It means my numerator have to be multiplied by a y, right?
Mm-hmm.
Okay, and how about the last term?
The last one, you're gonna multiply by y squared over y squared.
Yeah, so it's gonna give me 6 y squared.
Yeah.
Now I'm great. Now I have this common denominator. So I rewrite it. Now I am ready to combine my numerator. So now it's y squared, y squared, y squared. Now I am safe. This is my y squared here. 4 plus 10y plus 6y squared. And that's it. That's all we can do. Okay, very good. Right now we're going to do f. Are you guys done?
For
Done?
that one, for that problem that we just did,
Yes.
could we just leave it like that, or do
There
we
is nothing. There is nothing you can do.
do we reorder the top or no?
Oh, I don't care, honestly.
Okay, so we could just leave it like that.
I don't really care. I mean, I know that most of the book do it like this. It's the same thing.
Okay.
Okay, this is just because, yeah, I don't. At this stage, I'm all right. Okay. All right, now part F. Part F is the following. And part F is actually going to be again the subject of what I'm going to talk about today. Part F is they wanted to find all number C. Let me write in this color. Find all value of C such that f of C is equal to 42. Okay. So let me write my function here. I put it again in front of me because, so my function is x squared and what else? Plus 5x plus 6. Okay. So in this problem, what do they want me to do? And how am I supposed to do it? So I have a function. It takes an input, an output. I want to find all the c such that f of c equal 42. What does 42 represent here? Is it an input value or an output value? Back to you.
An output?
Exactly, it's an output. It's right here. And what do they want me to do? Find which input. What should I put here
Don't you have to solve for x?
We have to solve for x, exactly. So how are we gonna do it? Now, the book is calling it C, so they don't want to call it X because they want you to get used to a lot of ideas. So I'm going to put C. That means I want to find what should be the C. What should I put here? So I will spit out a 42. Basically, and we're going to solve. All right? So how I'm going to solve that? Let's see how we're going to solve. Let me basically remind you. This here, the highest power that C has is 2. Okay, and this is C. The best way or the only way to solve this type of problem is to rewrite it so one side of the equality has 0 only, and that's crucial. After we do that, we're going to factor and solve. So if I want this to be equal to 0, what am I supposed to do? So we're going to rewrite it so one side is only a 0. So to do that, I'm going to subtract 42 from both sides. My goal is to make it into a 0. So this is going to give me C squared equal to 0. So whenever you have square and C, that's the best way to do it. So this is going to give me, let me go back to this one, C squared plus 5C. Now 6 minus 42 is 36, right? Equal to 0. So whenever C squared and C are part of the equation, you have to rewrite it to make one side only 0. After we do that, let us remember, how do we solve this type of equation?
Don't you have to divide by C?
No. If I divide by C, it doesn't get me anywhere. I can't solve for it because I have a square. So the only way. What?
Do we FOIL it? Is that what it's called?
We have factor. No, it's called factoring. It's the opposite of foiling.
Yeah, factoring.
You have to factoring. Yes, yes. So let us factor. So we're doing the reverse process. Okay, so we factor. All right. So since this is C squared, it's going to be a C and a C. And what are the factors? Everybody's telling me 9 and minus 4 because that's 36, the number. And it should be plus 9 and minus 4. And now I usually, because I do mistakes sometimes, I usually FOIL back and see if I get the same thing. C times C, it's a C squared. C times that is minus 4C plus 9C, so that's correct, plus minus 36. So after I factor, I actually go back and make sure I'm doing the correct way. Now, what's the advantage of factoring? And what's the advantage of factoring and setting it equal to 0? The advantage is the following. If you have two numbers, A and B, and if when you multiply them, you get equal to 0, if the product is 0, it means that one of them is 0. So if I tell you A times B is 0, it means either this has to be 0 or this has to be 0. That's really why we set equal to 0. If A times B equal to 3, I cannot say A equal to 3 because A could be another value and B equal to 1 because A could be 6 and B equal a half and the product is always 3. However, if the product is 0, it means one of them is 0. That's really the importance of a 0 in the picture. So now if this is equal to 0, it means either this is 0, it means C equal minus 9. So minus 9 will make this 0. And this will give me C equal to 4. It means C equal to 4 will make this product 0. So the values will be C equal minus 9 and C equal to 4. So these are the values of C that When I plug them for input, they should give me an output of 42. Okay, and now let us check that we're doing it correctly. How can I check? Jared, how can I check?
Wouldn't you plug them into the problem?
Plug them, yeah, which problem?
Like you'd plug -9 in for C.
In the output, in the formula for f of x. So we're gonna check that. So suppose C equal to 4, I'm going to compute f of 4. If I get 42, I'm safe. If I don't get 42, I'm doing something wrong. And I write again the function here. That's my output here. Okay. F of 4, actually we've done it. It's 4 squared plus 20 plus 6. 16 plus 20 plus 6. That's 42. That's correct. Now I'm going to check -9. So I'm going to evaluate at -9. And I should get 42 because that's really the output I'm looking for. This is -9 squared plus 5 times -9 plus 6. We evaluate. This is 81. 9 times 4, 45 plus 6. And you can, if you want, plug in those into a calculator. And I get, honest to goodness, 42. So my values are right. Those are the input I need to put to give me an output of 42. Okay. Questions? All right, now I'm gonna move on to problem number 3, I guess. And then we'll start the new material. Number 3 is along the same line, but it gives us a good practice for fraction. And that's why the main reason I assigned it. So number 3. My function now is x over x minus 6. So now my rule, you give it an input. My f will spit out whatever you give it divided by whatever you give it over -6. That's really what my function does. So I will do the first one, which is the simpler one, and then I'll let you do the rest. What does f do to 4? 4 is my input. What f do to it? It's 4 over 4 minus 6. 4 minus 6 is -2, which gonna give me -2. Okay. Now, f of, the pencil, my favorite pen, is not working. Okay, let's see if this one works. So f of 1/2. Okay, I don't want to do that. I want you to do it. Take a scratch piece of paper. If you're taking notes, do it on your scratch piece of paper. And I'm gonna, then I give you a minute. And then I'm gonna ask one of you to tell me what you came up with. All right? So I want you to do it because it's not, get going. Please turn your camera on. Anybody ready? Okay, I'm gonna pick Amanda, Zach. Are you ready? Amanda? Okay. Matthew? Matthew, are you with me? Okay. Peter, are you with me? Let me know what you did. Go ahead. I don't care if you do it wrong or right. I don't really care at all. Whatever you came up with will follow you. What did you do? Peter, are you with me? No, I can't hear you. Probably your mic, your microphone, you're muted. Unmute yourself. You're muted. Can you unmute yourself?
Can you hear
Great.
me?
Yeah, I can hear you. Get going.
Okay, so I just
Oh, you're muted again. All right, anybody else? Tell Peter fix his problem. Anybody is ready? I'll get +1 to the one who will do the problem.
I got stuck, but
Oh, get going. Get going.
So what I did was I, substituted. So I did 1/2 over 1/2 minus 6.
Okay.
So I think that you have to find the common denominator for the ones in the denominator.
Absolutely, absolutely correct. Absolutely correct. Keep going.
Okay, so I multiplied, I put a 1 under the 6.
Yes.
And then multiplied that by 2. And then multiplied the 6 by 2.
Very
and then
good.
that equaled 1/2 over 1/2 minus 12, or yeah, 1/2 minus 12 over 2.
So far, so good. Keep going.
And then the part that I stopped at was it equaling 1/2 over negative 11 over 2.
So far, very good. Are you with her? Okay, so she found this is a mess here. So we try to simplify it. She find the top is fine. I don't have to work with it. Find a common denominator. She find the common denominator. And then this gave me -11 over 2. Very good. Now this is equal to what? What are the fractions rule? You have one fraction divided by another one. How do we do that?
Don't you just subtract?
No. Remember, if you have a fraction a over b, divide it by another one. Divide it. It's equal to what?
Don't you multiply?
Right, you multiply by the reciprocal of the denominator. Put this rule clearly in front of you. So how are we going to apply it here? The numerator is 1/2. What are you going to multiply it by? The reciprocal of that. So go ahead.
2 over 11, -11.
Negative. Oh,
-2 over 11.
It doesn't matter which one you put. So if you put 2 over -11 or that's really the same. But I'm going to put parentheses to do that. Is that clear? That's how we divide fraction. So now this is equal to what? Now, can we do better than that? Can we simplify the 2 and the 2? So it's going to give me basically, it's 2 over 2 minus 11. And now in math, if you have 2 multiplied by 3 over, let us say, 2 multiplied by 5, if you have a multiplication, you can simplify if you are multiplying. When you cannot simplify if you have an addition. So suppose this is 3 and this is 5. If you have an addition, this is not 3 over 5. Means you cannot simplify if you're adding. To be able to be simplified, you have the 2 has to be a factor of the numerator and a factor of the denominator to be able to simplify. In my problem, 2 is a factor here and a factor here. So this will leave me with minus 1 over 11. End of the problem. All right. So that's how we're going to work with fraction. Now, as an application to that, I will push forward and I want to do number D is easy. So we'll do number D together, but I will let you work on number E. So D is find an expression for f of t minus 1. Sorry, that's C. Okay. Who would like to answer this question? Okay. Anybody would like to do it?
Can I ask a starting question?
This is it right there.
Huh?
That's the f of x.
Right. I just want to know a starting question. So like I wrote it out. Can it be canceled immediately?
I don't, which question you're asking, B or C?
C.
B, okay. What's your
No,
question?
C as in cat.
Ah, C, sorry. Okay.
It's okay.
What was your question?
Okay, so when you substitute it in, I guess like my question is, can it be canceled out immediately?
Substitute. And let us answer your question after you substitute. What do you want me to substitute here?
So it'll be t over 1 or t minus 1.
Right.
Over t minus 1 minus 6.
Right.
So can t minus 1 cancel out?
Absolutely not.
Not yet.
No. Why? Because in the denominator, suppose I give you this, because that's crucial. 2. Forget about the problem for a second. Over 2, let us say, plus 3. Are you with me? All of you. Can I cancel those 2's? Is it correct mathematically? And the answer is absolutely not. The reason is I have an addition here. We cannot, and now think about it. 2 over 2 plus 3 gives me how much? It's 2 over 5, correct? If you simplify, I don't know what you get. I mean, if you simplify what you get, 1 over 1 plus 3, this is 1/4. It's definitely not 2 over 5. So you cannot simplify if you have an addition. You can simplify if what scenario is. If you have 2 over 2 multiplied by 3. That's when you can simplify. And you're left with 1/3. Are you with me? Okay, so this is going to give me what now? I cannot simplify. I cannot touch this. This is going to give me t minus 1 over t minus 1 minus 6, t minus 7. That's it. That's the answer. Nothing could be done about it. I cannot simplify t and t here. I can't do that because I have a subtraction here. I don't have a multiplication. So the answer is going to be t minus 1 over t minus 7, and that's it. Nothing could be done about it. All right? Very good. Now, I want to do E. And again, I want you guys to do E in front of you. And we discuss it. So E is f of 2 over y. And I will write in red the formula, so to keep it in front of us. Okay. All right, so please get going, and you and whoever is ready, you can communicate with us.
So f of 2 over y will equal 2 over y over 2 over y minus 6 over y.
Not y minus 6 over y.
Yeah.
Why did only minus 6? There is no y yet, because your input is 2 over y. So whenever there is x, you have to put 2 over y. So it's 2 over y,
Okay.
2 over y minus 6. That's the first step. Okay. Now proceed. Simplify.
It would still be 2 over y.
That's 2 over y.
And then would you find the common denominator then, which would
Exactly.
be y?
Yeah, for this piece now.
So
this
you just
is
do your first step, and then after that, that's when you do your.
algebra.
Okay.
That's the algebra part.
Okay.
Okay, that's the setup. That's the algebra. Are you with me?
Yep.
Finish the algebra for me. Get going.
2 over y minus 6 over y.
No.
No.
No, that's okay. Minus what? What's the common denominator here? Don't let y bother you. Don't let y bother you. If instead of y, think about it in numbers, but then use y. If instead of y, let us say you have a 3, what would be your common denominator? What would be your common denominator?
3.
3, right?
Yeah.
If you had 2 over 100 minus 6, what would be your common denominator?
100.
If you have 2 over y minus 6, what's going to be your common denominator?
Y.
Y. Exactly. Don't let y get into the way. So the common denominator is y. Okay? Now let us finish. This would become what? So the
Minus
6
6y over y. 6y over y. Okay.
6y over y.
Okay.
All right?
Yep.
Now, it's going to be equal to what now? The numerator is nice. I'm not going to touch it. It's this that's really giving me problem. All right. What's the benefit of having a common denominator? What's the benefit? Why we do it?
You can factor it out.
No. Why we find a common denominator?
You can combine them.
We can combine the numerator. Exactly. We find a common denominator because, as I said last time, if I have 2/3 plus 5/3, it means you have, basically you have 2 pieces of length 1/3. You add another 5 pieces, So that's the 2. 1, 2, 3, 5 pieces. So it's the same size pieces, basically. Each one is a third, so you can combine them. You get 7 pieces of size third. That's why if you have a common denominator, we can combine the numerator, and that's really the benefit of it. So here, if the common denominator is y, it means I can combine the numerator. And this will give me 1 fraction divided by 1 fraction. And this simplifies the problem. So now, what can I do with that? If you have a fraction divided by another, how do we manipulate this algebraically?
Multiply by the reciprocal.
Which is, what is it? It's 2 over y. Keep going.
Times y over 2 minus xy.
Absolutely correct. Okay, that's the benefit. Now I'm going to take you one more step. Can we make this better? So basically it's 2y over y times that. Because multiplying two fractions, you multiply the numerator over the denominator. Now can we improve on this a little bit? Anybody?
Can you not distribute it, like multiply it by the y?
I can.
Like
I can do that. It's correct. But we can do something else which will simplify the expression, if possible. What do you think?
Can you divide by y?
Yeah. Why can we do that?
Because you have y standing alone in the numerator and the denominator.
Right. It's a factor. Factor. You know, it means 2 times y and y times this. I can simplify them. I cannot simplify if you have 2 plus y. I cannot touch it. If you have 2 times something, y times this could be simplified, and it will leave me with that. Okay? So the reason I can simplify by the y, because it's multiplied. It's not really added, it's multiplied. So it's a common factor for the numerator and the denominator. It's a common factor for the numerator and denominator, so we can simplify the common factor. It's not a sum. Okay? No. Part F, I will not do it. I'm going to assign it for next time. And I insist that all of you do it as a practice problem, because it's crucial to be able to work with fraction, which is what's the goal of this review.
I have a quick question.
Please go ahead.
For in the problems, when you give the solutions for it, it's a different answer.
What is the answer?
In the book.
It should be the same.
In the book, it says it's 1 over negative 3y plus 1.
Very good. Who can get me from here to here?
Simplify.
How? Correct. How?
You divide.
You just divide the 2.
Yeah. Why can I divide by 2? Watch carefully. If I look at the denominator, can I factor the 2 out? Means can I put 2 as a factor here? Yes or no? There is a 2 here. 6 is 3 times 2. So I can basically factor out the 2, and I will be left with 1 minus what here if I factor the 2?
3y.
Yeah, because distribute, you get 2 minus 3y. Okay, so the idea is when I see 2 minus 6y, I said, 2 is a factor of 6 because 6 is 2 times 3. So if I factor out my 2, that's give me a 1 minus. Since it's 6 is 2 times 3, what's left is 3. 1 minus 3y. So I can factor this out. And now 2 is a common factor to the numerator and the denominator. I can get rid of it. And I will get 1 over, now according to me, is 1 minus 3y. But this is the same thing as I put minus 3y first, plus 1. So the book went a step further and realized that, okay, the 2 is a factor of this term and a factor of 6. So I can factor it out, leaving me with 1 minus 3y. And then we get rid of it. Any other questions? Does this answer your question?
Yeah, it does.
Makes sense? Good. All right. Anything else? All right. So as I said, I'm going to assign F again, because after what we did today, you should be more capable, ready to do part F. And I will check with you next time, see if you guys got it correctly. So what we're going to do today is, again, we're still developing algebraic skill. And section 1.7, I guess, is nothing more than more algebraic skill. So more algebraic skill. And what you're going to emphasize in this section, what you're going to review is solving equation. So suppose I take this problem here. F of x equal, what do I mean by solving? F of x equal x over minus 6. And I ask you, find x, or find the value of c, such that f of c equal, I don't know, equal to 8, for example. So how we do that? It means I'm asking you, what should you put here so that the output is 8? So the question really boiling down to solving this type of equation. So what we're going to do today is actually kind of review how to solve equation. And that's where 1.7 is about. So I'll start with a very simple equation first, and then we build up slowly. So the basic equation, the simplest possible equation you will encounter will be something like this. So suppose I tell you, solve the following equation. Let us say, very easy. 2x plus 4 equal, let us say, 5x minus 1. Okay, solve it for x. Now here, the power of x is 1. So the way to solve this usually is to try to put the x's together, isolate them, and the constant term together. So we're gonna basically, the trick is to isolate x. That's really what we want to do. All right, I know that you guys can do this, so I want you to tell me what you want me to do. How can I isolate my x?
Add 1 to each side. Oh,
Add 1 to each side?
yeah.
Okay, so it's gonna give me 2x plus 5. If I add 1, I'll get 5x. Okay, still, I want to isolate the x. So what do you want me to do next? Very quickly, because that's a simple one.
Minus 2x on each side.
Okay, subtract 2x equal to. I take away 2x here. I will be left with 5, and I'm going to take the 2x from here. So now this will give me 5 equal 3x. I'm almost having everything in x in one side equal to 5. Now to isolate this x very quickly, what am I supposed to do?
Divide by 3.
Divide by 3. And then I will get x equal 5 over 3. Okay, the first type of simple equation we solve. Here, that's the simple in the sense that the power of x is 1. I don't have x squared. The minute I hit x squared, the problem will change. Right. Another type of problem, like the one I started to motivate the lecture with. So suppose, again, I'm asking you to solve the following. X over x minus 6, that's the one I did a minute ago, equal, let us say, to 8. And I want to find which value of x I can put here that spits out in 8. Okay, how do we do something like that? Anybody has any idea?
Would you multiply
by,
The x minus 6 times 8.
yeah, multiply across, if you want, by x minus 6. Because the idea is I want to get rid of this x minus 6, which is really kind of problematic. So I multiply both by x over x minus 6. Okay, multiply both. Now multiplying. The benefit of this is that x minus 6, that's a factor of the numerator, factor of the denominator. This one now can be simplified. And then I get 8x equal. I distribute my x here, 8x minus 48. Okay, so the goal is this x minus 6 is problematic. So I multiply both by x minus 6 because if you have 2 times 3 halves, usually, so I have 2 and 2 here, this is 2 times 3 over 2 times 1. This is actually equal to 3 because if it's 2 is a common factor, numerator, denominator, I can factor by 3. And that's the same thing. If I have x minus 6 times x over x minus 6 multiplied. So this is basically x multiplied by x minus 6 over x minus 6. Those simplify and gives me my x back. So that's really the benefit of doing this. Now, when I am at this stage, is it easy or hard?
Easy.
Easy, very easy. So now I can add 48 to both, giving me x plus 48 equal 8x. Subtract x, give me 48 equal 7x. Now we can divide by 7 to get rid of that, and I will get 48 over 7. Okay, so it's not hard to handle it. The main thing is multiplying by x minus 6. That's really the heart of solving those type of problems.
Would it be okay if you did minus 8x?
Yeah, it doesn't matter. Absolutely.
Okay.
It doesn't really matter at all. All right?
Okay.
Absolutely not. Very good. Let us do a little bit more solving. That's really what we're going to do now. Solve the following equation. And I'm gonna, okay, suppose I tell you to solve the following equation. 2 times the square root of x equal to 5. Okay, I will let you think about it, and then I want you guys to tell me, what am I supposed to do? Please, every one of you is responsible for doing the work. So we have square root of x, which is bothering me, it's bothering you. We have to do something to basically bring x to the picture.
Would you divide?
Divide what?
Would you divide the 2 to both sides?
Okay.
To have the x by itself?
Right, so your friend said, right, your classmate, sorry, is that she wants to isolate the square root of x, so we can have it by itself. So how to isolate the square root of x? So we need to isolate the square root of x. So we divide by 2 to isolate it. Okay, so I'm gonna do that verbatim. So the square root of x is 5 over 2. I isolated the square root. And then quickly, what should I do now? I wanna get rid of the square root. How can I get rid of it?
Square root for 5 over 2.
What?
Square root 5 over 2?
No, no, because this is the square root of x. How can I get x back? The idea is to get rid of the square root. How can I get rid of the square root?
You give x the power of 2.
Right, I can square both sides. What's the benefit of squaring? Squaring basically cancel the square root. So if you have square root to the power 2, this would give me the x back. So the idea is I want my x back. Now, if I square this, I have to square the other time. So remember, what's the definition of the square root? What's the square root of x? It's the number. When you square it, what is the thing? When you take it to the power 2, you get x. That's what the square root of x. So square root of 4 is which number? To the power 2 gives you 4. That's 2. So by definition, the square root is the number. When you take it to the power 2, it gives you x back. So now I need to square both sides. The benefit is I can now remove the square root problem. And it's going to give me x equal. Now 5 over 2 squared, this we've done it by now several times. It's going to give me 5 times 5 is 25 divided by 4. Okay, so if you have the square root of x, we first isolate it. And once we isolate, we ask ourselves, okay, how can I get x from this? So now I square. The square root of x squared will give me my x. That's the one I want. And then I squared both sides, will give me 25 over 4. Okay. So we did now 3 types of solving. The first one was a simple one. The second was, it looked a little bit hard. So when I took x over x minus 6 equal to 8, but the idea was multiply by x minus 6 and then reduce it to a simpler one. And the last one we did involve the square root. So whenever we have a square root, we usually try to isolate it and then go from there. Now the last problem is the following. I'm going to use functions to do it. I'm going to take, let f of x be equal to x squared minus 3x. Okay, so now I'm going to go back to functions. And okay, so let f of x equal. Okay. So if I graph this function, it means I put here all the x value, and I make a table, and I take different input, and I find the output, and I try sketching, I'm going to get this type of picture. Okay, so that's the graph. Okay. All right, so we can use our calculator, or we can take a bunch of points and see what we get. Now I'm going to ask questions about this function. Question number 1 is, suppose I want to find those 2 points. It means I want to find the value of x, those intersections. What do you think my question would be? Before I put it, I want to ask you, what do you think I want my question to be? What happened here? What happened here to the output? What's the output here? If I want to find the input here, what's going to be the output? If I take this point, what's the output? What's the y coordinate? 0. What's the y coordinate here? 0. So if I want those 2 points, I'm going to ask you find all the value where f of x is equal to 0. So if I'm asking you this question, it means I'm basically asking you where the graph is intersecting the x-axis, where the output is 0. So that's one code. So how do we do that? I'm going to set this equation equal to 0 and solve for x. Here, I'm looking for those points. This is really what I am asking for. Now, how do I solve for this equation? This side has only 0. And now we have x squared. It's not x anymore. How do we solve when we have an equation like this? Anybody? There is a keyword. the keyword is, whenever you have square and x, the keyword is factor. The keyword is to factor. All right, how can I factor this? X squared minus 3x.
Do you plug in 1 for x?
No, I want to, you know what factoring means? Do you know what it means to factor?
Wouldn't it mean breaking it down to two separate like parentheses?
Yes, right. It means write it as the product of two things. And how do we do that? In this particular, is there a term here that could be factored? Is there
When we take out the x?
Yeah, x is a common factor here. And then what are we left with? If I take x as a common factor, what am I left with here? If it's x squared, because what's x? This is x times x. If I take one x out, we'll be left with x in here. Minus. This is 3 multiplied by x. So basically, I'm factoring out this x. And I'm going to be left with x from here minus 3. Okay, so whenever we're solving, we're actually factoring. Now, if this is equal to 0, what does this mean? Which value of x will make this 0? It means everything that makes this 0, so if x is 0, the whole thing will be 0. And everything that makes x minus 3 0 will make the product 0. X equal to 3. Okay, so let's go back now. How to solve x squared minus 3x equal to 0? We factor it out. So how do we factor? In this particular problem, we ask ourselves, is there a common factor here? If we look at it, we say, okay, this is x times x. This is 3 times x. So I can factor out my x. So I will be left with x minus 3. And then how can this be 0? X 0, x minus 3 equal to 0, which give me x equal to 3. Now, in the picture, what does it mean? This is the graph. It means right here, that's my first 0, and this is here. And that's really why we're interested in it. It means we're asking ourselves, when does this function intersect the x-axis? Right here and right here. Okay. All right, now I'm going to ask again. So we are solving by interpreting that as, so this is really a solving problem, but the meaning of the solution are those points right there. So now another question.
If we were to just plug it into the calculator and
Yes.
give you the answer, would that be acceptable as well?
No, absolutely not. Sorry about that. You can use it to check your answer, but not to do the work. Are you with me?
Yeah.
Because sometimes, the answer could be, I don't know, like 3/7. Okay? Do you think you can figure out 3/7 on a calculator? It will be very hard. Because the calculator, you're going to tell me it's 0.3, blah, 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 blah. You can never figure out the exact value. So it's crucial for us to be able to do it this way. Okay? B. I want you to find all values of x where f of x is equal to 4. Okay, so what am I asking for here? My 4 now is an output, like I did before. I'm asking which input, what shall I put here for input? What should go here? So when f take it to 4. That's really what I'm doing. Graphically, I will get back to the graphically after that. So when I set f x equal to 4, so what is f of x? Means I'm asking here, what should go here? What number should I put here so that when I output it, I get 4? Okay. All right. How do we solve this type of equation? How do we solve that? Step number. Yes.
I was gonna ask if the first step is to make the other side of the equal sign 0.
Crucial step. We have to make one part equal to 0 and only 0. So we're gonna manipulate it to rewrite it equal to 0, like the problem I did before. Crucial. So if I wanna make this to be equal to 0, I have to subtract 4 from both sides. Okay, so we have to make one side only 0. This is when x squared is into the picture. Not when, if I only have this, we don't need this. We already know how to handle it. The minute x squared in the picture, one side has to be 0. And then what should we do after that? Once you write it like this, what do we do after that?
Factor.
Factor. So these are the steps. So whenever you have x squared minus and an x in here, step number 1, one side should be made totally 0. Step number 2, we're gonna factor it.
Professor, I have one
yes,
question.
Of course.
When you bring the 4 over to the other side to get 0, is it still positive or do you change it to minus?
Subtract 4.
Okay.
Right?
Yeah.
So if I subtract 4 from here,
okay.
Get my 0, I have to subtract 4 from here.
Okay.
So I cannot tell you plus or negative. It depends what I have on the right. Right? Now factoring means it's the opposite of foiling, basically. I'm doing the opposite. So, okay, everybody is telling me, they're telling me that it is, so this is my x, and the students are telling me minus 4 and plus 1. Okay? Usually because I doubt myself, after I factor, I basically try to go backward. I try to again FOIL or distribute and see if I am right. X times x, x squared, plus 4x, minus 4x, that's correct, minus plus minus 4. So the way we factored it is correct. It means those two terms, those two expressions are exactly the same verbatim. Now the benefit of factoring is, I am looking for the x that makes this 0. It means I'm looking for the x that make this expression 0 because they are the same. So now I said, what make this one 0? And then I say, okay, every x that make this term 0 will make the whole thing 0 because that's a product. So what make this 0 is, if x, every value that make x minus 4 0 will make the product 0. So if x minus 4 is 0, it means x equal to 4. That's one value. Everything that make this 0 will make the product 0. It means every x that make x plus 1 0 will make the product 0. If x plus 1 is 0, x equal minus 1. So which x's I should put here that spits out the 4 is actually x equal 4 and x equal minus 1. Okay, so that's really the idea how to solve when I have x squared and x. Now the last point before I talk a little bit about Moodle is the following. I'm going to go back to the graph and connect what we did to the picture. So the picture is, this is how the function looks like. Okay, so this was my 0 and this was my 3. In this particular problem, all the x's at fx equal to 4. What am I asking for? This 4 here, is it on the x or the y axis? How do I view it here? On the vertical or horizontal? This 4 here.
It's for y. You look for it on the vertical.
Right, because that's an output. And what am I asking for? Every input that's mapped into 4. So basically what I'm asking for are those 2 points on this graph, this and that, this point. So I gave you the y, and then I asked about the x. So this is gonna be the minus 1 on the picture, and this is gonna be the 4 on the picture. Okay, so basically I'm thinking, when is the function takes the value 4? For which input? So for minus 1 and for 4, okay? All right, so this is for today. For next time, please, you do the practice problem and you have to do the Moodle problem. Now, I checked you guys, a lot of you haven't even tried to connect to Moodle. It's becoming very late, even though I sent, I don't know, 2 messages by now for you. Please.
Blowing my stuff up.
What? I can't hear you.
Nothing.
Okay, so I'm gonna share the screen to tell you how does this Moodle work. I take a typical example, and I want you to get to use the registration, use the information I put online to be able to use Moodle. So let me share the screen, how it works.
I don't know if it'll be the same for everybody else, but for me, I had to have them resend me my password because I didn't know what my login was.
Okay, let me show you the screen, share screen, and then I answer those questions, all right? Okay, so. And then I know that some of you had difficulties, we'll talk about them. Okay, it's time's out, all right, it time's out. I have, I think, two. So your class is, this is your class? Okay, sorry, I have to log in again. Okay, very good. So let me take an assignment. That's the assignment I assigned to you, this one. And I'm gonna pick a problem, one of those problems. So let me make the screen bigger. Let me see. I'm picking up a hard problem. I pick an easy problem to show you what it does to you. Okay. So for example, let's consider the following expression: minus 2s plus 5 times 4s plus 1. And the question is, enter a. So this is an expression. They want you to multiply it out like what we are doing. And the first one is entered but not simplified. And then the second is entered but simplified. So I'm going to do it with you. And if I do any mistake, let me know, because sometimes I don't see very well. So minus 2s times 4s is going to give me minus 8 s times s squared. So I'm inputting my answers. Minus plus, so it's going to give me minus 2 times 4, that's 8s. If I'm doing any mistake, let me know. Plus, because I don't want it to simplify, 5 times 4, 20s. And then plus times plus, it's a plus. 4 times 5, it's 20. But I'm not going to put 20. That's the only mistake I'm going to put. So I'm going to put 19. Are you with me? So I did a wrong answer on purpose. Now, enter A, expanded and simplified. It means I want you to connect stuff. So according to me, I get minus 8 s squared minus 8 plus 20, which give me plus 12s. So I'm connecting like term plus 90, which is, I know there is a mistake, but that's fine. And now I hit save answers. So Moodle will tell me your answer was interpreted as follows. So this is the answer that I input. If it's the answer that you wanted to give, is this the answer? If so, click the check answer button again. If it's not, fix it. So let us say that's the answer I want to give. I put save answer. I save it. Now, Moodle give me a feedback. It tells me your answers are incorrect. Okay, so it tells me that. Your first comment on your unsimplified answer, on the first one. This is not equal to the original one. So it's telling me that whatever I entered is not exactly equal to that. And of course, it's telling me that the simplified one is not equal to the original one. So Moodle told me that I'm doing something wrong. So I go ahead and fix it. I do the problem again. Suppose I fixed only the first part. It was supposed to be 20. Okay, I fixed that. Save answers. Very good. Now, again, it interprets my answer and tells me if this is what I want. If I'm satisfied, I save my answer again. Now I go back and see what feedback it gives me. It tells me your answer is partially correct. Why? First comment, the unsimplified one is correct. So now at least I know that part of it is fine. But the second one, it tells me it's not equal to the original expression. So now I know that I still have a mistake. So I go and I fix it. So this one, I fix it and save answer. Tell me, is this what you want? Yes, that's what I want. Then save answer again. Okay, and now I go back. You answered in this question 3 times. You attempted blah, blah, blah. Your answers are correct. So now I know that my answer is correct. Now you have the right for 4 attempts, no more. After the 4 attempts, you're done. Your answer is wrong. So that's really how Moodle works. And I assigned 7 problems for you for Tuesday at 12 o'clock. Okay, so for Tuesday, you should do the practice problem because they are crucial. And also I want you to do the Moodle problem and get the feeling for it. All right, any questions about that?
Yes, I was wondering how you access your password.
On Brightspace, I have a registration form, an instruction for you. Okay, if you go to Brightspace, and I emailed it to you as well. So if you go to Brightspace, here, go to Brightspace, that's your home page, that's your class, and online homework. Did you guys see that? This gives you all the instructions you need to connect to Moodle. Okay, so Brightspace does not connect to Moodle itself. It doesn't work with Brightspace. Every time you have to do the homework, you have to go to the website, Moodle website. It's not through Brightspace. You have to go to the site itself. So bookmark it on your computer or wherever you do the homework, because you have to go back to it to be able to do the homework. So all the instructions are here. You click on instruction for the inline homework. You get 3 or 4 pages of instructions. I think they are very well written because they are basically written by the person who is administering all this stuff. So he wrote it very well and follow the instruction verbatim. Okay, and if you really, nothing is working with you by following the instruction, and then you let me know and we see what we can do after that. Any other?
So the instructions actually didn't work for me, but in the instructions, it says for you to use your PNW username, but I
Yes.
had to use my email, and that is how I got my password instead.
That's what you, yeah, okay. So you're gonna pretend like you have an actual account, and then you're gonna click forget password, and it's gonna send you a reset password to your email, and then it's gonna give you a username and password, but it's gonna be a really weird username.
Okay, other questions? Anybody else? So please make sure you connect to Moodle because, because, I have to know, I want all of you to be on it. And if you have a real serious problem, I will have to talk to the administrator because I'm not administering it. Somebody is administering it. So you have to connect. Let me know if you have a real issue and I will send them to the administrator. So, but don't postpone anymore. All right, any other questions? What questions?
Yes, I got a question. So look, check this out. Here's my problem here. Like I'm typing in the username and password. I mean, the address, and it doesn't work at all. Like I know I'm supposed to get emailed instructions.
Did you get an email from Moodle?
No, I never did either.
You did not get an email from Moodle at all?
So
I didn't get
I
one
had the
either.
same issue, but I solved it. Instead of putting in your username, you have to put in your email, and then you'll get an email from Moodle because it'll be like,
okay.
I might have. Let me refresh.
All right, you guys stay. If your classmate solved it this way, so let's see what she's doing because.
Yeah, she's right.
Oh, great. So what did you do?
I did exactly what she told me to do. Just put your email address in instead. Just get the username. Just put the email address in, whatever your last name is at PNW, and then you'll receive a email for instructions.
Great. For the password.
Mm-hmm.
Did it work for you?
I got a quick question.
Go ahead.